Hi, and welcome to Python for Real Beginners. My name is AT, and this is the second of the series about learning Python programming. In the previous video, we focused on creating the environment to run the codes for Python, and today we will be looking at numbers and doing simple calculations. Here is the outline for what is going to be explained in this video. I'm going to briefly show you the Python programming environment that is going to be used in this video, and after the platform is set, I'm going to introduce you the numbers that can be used in Python. Then we will do simple and compound arithmetic expressions. So let's begin. For this video, to demonstrate what one can do with Python, I'm going to use a browser-based, no installation required website called Python Anywhere. If you're interested in this, access the website and sign up for a free account. So once you access and log into Python Anywhere website, click on the Files tab. You will then get to a page that looks like this. Once you reach this website, under the Files, type in numbers.py and create a new file by clicking the New File tab. Once you do that, it should direct you to a new page that looks like this. So now that your Python environment is set, I would like to start explaining about the numbers that you can use in Python. The most basic type of numbers in Python is integers, or abbreviated as int in Python. These are regular whole numbers, and there is also a notion of real numbers called floats, short for floating point numbers, where decimal point floats around the numbers. Floats are not real mathematical numbers, so there are some limitations in the Python program, and one of them is precision. You'll lose some numbers when you type in lots of numbers because Python only takes an approximation of the numbers, run the numbers up randomly, and Python is being nice by keeping the numbers simple so it is easier for you to look at. So keep in mind that there is a limited precision in the numbers that are being printed. Also, it is possible for you to use scientific notations, and Python can give you back scientific notations as well. For example, 5a42 means 5 times 10 to the positive 42nd power. They can also have negative numbers, can be 5 times 10 to the negative 42nd power. Also, if you print lots of 9s like in the example, you will get 1 in the output because Python is trying to keep numbers in sort of finite amount of space, and rounded the 9 into 1 and printed as 21 zeros after it. These numbers doesn't continue like this forever because eventually space runs out and becomes infinity. Python has a notion of infinity, and if the numbers are too big, Python will give you back inf, which stands for infinity. It is also possible for you to get back negative infinity. It is possible to use inf as numbers, but if you add something to inf, you will always get back infinity. That was a lot of information, and it might be possible that you forget what is an integer and what is a floating point. There is a very useful tool within Python that can be used to know what type of numbers they are. So for instance, in this example, x equals 3, and if you want to know what type of number the value x stands for, you can use what is called the type function, or type followed by parentheses. Inside the parentheses, you put in the value, which in this case will be x. The output will be as shown, class int, so x is classified as an integer. If you say y equals 5.9 and print out type parentheses y, you will get class float, so you know y is a floating point number. As for the example of z equals, recall in the previous slide that negative 1 in 500 was described as infinity, but here, when we use the type function, we get class float. Thus within Python, it is classified as floating point number. This type function will be useful as you learn more about Python. And also remember that whenever you want to see the results in the output, it is necessary to use the print function, or print followed by parentheses and the value you want to look at. Another useful tool that exists within Python is the FloatEnd function that allows you to go back and forth between integers and floats. For example, the integer 3, by using float parentheses, can be converted into a floating point 3.0. Similarly, if you type in lots of integer 9s, it gives you back a scientific notation of 1 times 10 to the 38th power, which is a floating point. Similarly, by using end parentheses, you can convert a floating point into an integer. However, you have to be careful here because it does not round off the numbers. So if you type in 3.7, it will give you an integer of 3. You can also use end and float for negative numbers, and it will give you back negative valued numbers. Again, the usefulness of this function will be looked into as we further advance with this series of videos, so if you're interested in it, stay tuned. So now that we have looked into the numbers that can be used in Python, let's do simple calculations. You can add and subtract using a plus sign or minus sign. If you add integers, it will give you back integers. If you add floating point numbers, it will give you back floating point numbers. However, when one of them is an integer and the other is a floating number, it will give you back a floating number by converting the integer into a floating number. So for instance, in this example 3 plus 6.7, the integer 3 is converted into 3.0 and the output is 9.7. The same rule applies for multiplication, and multiplications can be done by using asterisk marks. When doing division, you can either use a single slash or double slash depending on the following points. Single slash gives you back a floating number and double slash gives you back an integer. So when it is 3 divided by single slash 2, it will give you back 1.5, whereas in double slash it means integer divide. So 3 divided by double slash 2 will give you back an integer 1, throwing away the 0.5, or in other words, it throws away the fraction. But what happens when you use double slash with floating point numbers? Would it give back an integer? Not quite. It will give you back an integer, convert it into a floating number, as in the example provided here. So basically, it will throw away the remainder and give you back the floating number, in this case 0.0. It's a bit confusing at first, but the takeaway message here is that remember that in Python, numbers can be thrown away and they are rounded up randomly, so don't forget that numbers in Python are limited in precision. Lastly, let's look at exponentiation. So you can raise numbers to powers in Python, and you can do that by using double asterisks, as in the example provided here. Note that if both numbers are integers, it will give you back integers. If one of them is a floating point, it will give you back a floating point number. So in the last slide, we looked at the simple arithmetic expressions, but in Python, you can also do some other complicated arithmetic expressions, like adding and subtracting multiple numbers or doing a max of addition and subtraction. However, when doing addition and subtraction with multiplication and division or with exponentiations, you have to follow some rules similar to the ones you follow when doing these mathematical expressions on your own. So for instance, when solving 7 plus 3 times 5, you will start solving the multiplication first, then the addition. In Python, the precedence of operators are evaluated in the order of numbers inside a parenthesis, then exponentiation, followed by multiplication and division, then addition and subtraction. When they have the same precedence, such as doing addition and subtraction, they will be evaluated from left to right. Despite these rules, it is always safer to use parentheses to define order, so group the mathematical expressions with parentheses, and this way you can control exactly the order which things get evaluated. So the take-home message will be, whenever you get confused with the operator precedence, just use parentheses. So to sum up what was covered today, we looked at numbers that can be used in Python such as floats and integers, and learned that there is a limited precision when expressing these numbers in Python. We also tried to figure the type of number it is by using the type function, and learned to convert between floats and integers. We learned doing some simple arithmetic expressions as well as compound arithmetic expressions in which parentheses were considered important when defining order. So this is it for numbers. We will learn about new terminology such as values, assignment, and functions in the next video. We already used some of these terminologies in this video, but up next we will look further into those terms and learn how to use them. Hope to see you next time!